this is just about the last talk on Sunday, so it's my responsibility to take those of you who are still here and to really rile you up. So I decided to pick a very controversial topic, which is does code quality really matter? Now, before I get into that, just want to give some basic details. We're at ODSC West. It's Sunday, November 15th. And I'm James Powell. You can follow me on Twitter at Don't Use This Code. You'll see why. So, hi everyone, I'm James. Hi everyone, I'm James.
Hi James.
Very good. So, I'm an advisor for ODSC West. I work together with NumFocus to help put on the PyData conference series. I do a lot of things in open source data science. I'm a Python consultant. I do Python training. None of you care about any of that stuff. But if you like this talk, you can see similar talks at any one of these conferences where I presented this year. So you can see this is the last conference presentation I'm giving this year at ODSC West. So hopefully I can close out the year with a successful presentation. Now, one thing that you might wonder is, how on earth can you attend that many conferences and give that many talks? And what on earth would you be talking about? Well, I almost never give professional talks, and the reason for that is, really, who cares? I mean, it's pretty boring to have somebody come up on stage and say, oh, we did this product, we did that thing. Here's some tiny library that I used to solve this use case. And honestly, most of the time the code for that stuff is over-engineered and not very good. So, I told you I'd shake it up a little bit. What I like to do is I like to talk about the avant-garde. And if you're familiar with what avant-garde means, the purpose of this talk and the purpose of the talks I give is to offend you, to shock your senses as technical people. So I'm going to give you a little demo to show you what that means. And then I'll segue into my actual talk. This talk that I'm giving today is not an avant-garde talk. It's unlike all the other talks I've given this year. It is a postmodern talk. And we'll see what that means. So, here we go. Some of you are Python programmers, some of you are R programmers, some of you are Julia programmers, or maybe the Julia programmer maybe left today, so it's mostly Python or R people in the audience. I'll show you something kind of interesting that I did in Python. I've never given a talk about this because I didn't know that the audience would actually be very interested in it. But let's say we pip install a module. It's a module I created. Oh, let's go down here, and we'll just set that up. And we'll pip install, pip3 install. It's Python 3. DUTC rwatch. And we just download the module and it installs. And we're all familiar, you can install a lot of stuff in Python as easily as that. What this is it adds read watches to Python. So I'm going to import rwatch. And from the sys module, I'll import get rwatch and set rwatch. And we'll see what get rwatch does. It returns the target set with sys.set rwatch. What garbage is this? What on earth does that mean? So let's look at the help for set rwatch and see what that does. It sets read watches for the specified objects. Well, what on earth could that mean? Well, some of us are familiar with debugging tools like GDB, and we've used read watches in GDB. A read watch in GDB is every time a variable is accessed, you're able to put a breakpoint on it. This module claims to be able to do that in Python. So let's try that out. We have a variable called x and set to 10. We create a watch function, and all it does is print something out. We saw some object at some frame, and we return the object. Then we do set rwatch with the ID of x, and the watch function. Now, every single time I try and access this x variable, it triggers this function. Well, that's kind of useful, because if I had a large system, and instead of wanting to put a breakpoint on a single line of code, I had some data item that was causing a problem, but I didn't know where along the lines it was covering things up, I could put a breakpoint on the data item. The moment it's accessed, I see exactly where it's coming up to works. And you can see this actually works very interestingly. So if I create a function that returns x times 2, and I call this with x, you can see it triggers the watch twice, one passing to the function, and one doubling it and passing back. Well, you might see something interesting in that. Whoops. You might say, well, notice that I returned the object. What if I did something like this? I raise an exception when you try and access the object. Let's set the watch again and see what happens. I can't access this variable. So with something as simple as rwatches, those read watches, I can now create very simple but robust sandboxing in Python. But there's something really neat. What if my watch, notice in the watch it returned the object. What if I did this? Watch, frame, object. If the object is an integer, and the integer is between 0 and 10, just return it doubled. Otherwise, return it. And then in the collections module, I'll import default int, and I'll set a watch on everything. So now every variable has a read watch on it. So the number 1 has a read watch on it, and so 1 is now 2. 2 is now 4. 4 is now 8. 1 plus 1 is 4. X equals 1, x plus x is 8. So you could really cause somebody to have a really, really bad day if you make 1 plus 1 in Python equal to 8. And notice, 10 is fine, 11 is fine, 12 is fine, 9 or 8, nope, 16, 9, nope, 18. That's really wild. Now the question, whenever people see this, they're a little bit shocked. See, this is provocative, right? Why on earth would you ever want to do this? What does this even mean? You're missing the point, which is, how on earth did I do this? How do you install a module that does this? I'll show you. So let me go into my little projects folder, and you'll see the code for it. If you go into this projects folder, code's all online if you want. You can see I have all the source code for CPython. And if I view ceval.c in the Python interpreter, you can find that every time you push a variable to the Python stack, I just run my watch function there. Well, that's kind of interesting, but the real question is, how on earth do you pip install a patch to a CPython interpreter without changing anything online? And that's the real question. I don't have time in this talk to go into it, but if you see my other talk about this that I gave at PyData earlier this week, I'll tell you how. That was an interesting little demo. And it's something that I have fun with, it's something that I like to play with, but it shows you what the avant-garde is. The avant-garde is, here's some really crazy thing that you can do in Python. Most of these projects are things that I do on flights because I'm bored and I have nobody to face but my own mortality. So I'm just there coding and I come up with something wild. Let's get back to the main question. Does code quality really matter? If you're here on Sunday, sitting here, you already know the answer. No, it does not matter. If you saw this presentation and you're a beginning Python programmer and you look at that and say, that's absolute garbage. Why on earth would I need to know how to do all these crazy things in Python? I just want to get things done. And you might ask yourself, do I really need to learn Python that well? If you're asking yourself that question, the answer is no. So if that's the perspective you're coming to, you can leave the talk now. It's pretty much over. I saved you 15 minutes of your time. Otherwise, let's take a look at the deeper question. But before we get into that, I'm going to give you a little meta talk. So we see this is an enormously successful event. We have over 1,000 attendees. And out of the 1,000 attendees, maybe 40 or 50 are speakers. And you might wonder, how do I join the ranks of speakers like me? But honestly, it's clearly not that hard. Just come up with some really bad ideas and are willing to present in front of an audience. So how do you do that? So I'll give you the process. This is how pretty much everybody gets started in speaking. So if you want to join the speaker circuit, if you want to switch your red lanyard for a blue lanyard, notice I have a black lanyard. How about that?
Yeah.
I'll show you how. Here's the process. So the process works like this. If you're Andy Muir and you wrote Scikit-learn, or you're Wes McKinney and you wrote pandas, or you're Jeff Reback and you maintain pandas, or you're Kenneth Wright and you wrote requests, you're done. You already made it. Give talks for the rest of your life about that. Nobody will learn. You can give the 50th pandas talk 10 years from now. People will still show up and see it. Great. But if you're a normal person like the rest of us, here's how it really works. You start by talking about something somebody else did. This is how I got started in talking. My very first conference talk was at PyGotham 2012. This is the local New York conference. I talked about decorators and context managers. I just showed people how they worked. All I had to do was research the topic well enough, and people had to have enough confidence that I could explain this. The next thing you do is you say, well, I want to go a little bit beyond that. I want to add a little bit of myself into it. So you talk about some small library or tool you worked on, or some not totally mainstream approach for how to do something. In many cases, you can take something that's successful in another language community and just copy it into your language community. You'll notice among the R, Python, Julia community, it happens all the time. So there are people in these communities who are famous for just taking something that somebody did in another language and porting it over. It works great. And there are certain people, I'll say in the R community, who are famous for basically restating what people have been stating for the last 20 years, just about R. That's how it is. And I did the same thing. So I started talking about generators, and a lot of those PyData talks, if you Google for my name in PyData, you'll see dozens of PyData talks, and a lot of them are about generators. This is me showing you unique conceptualizations of how to use them. In fact, I think at least one person in the audience has probably seen that talk, sitting right there. How'd you like it? Was it good? Thumbs up. Very good. Number 3. And this is the final stage of your evolution. You talk about your ideas. You talk about something controversial, and you have to have a message. So I keynoted earlier this year at PyTexas, and I took all of this nonsense that I do in Python, and I wrapped it in a message, and it made for a pretty decent keynote. That's how it works. You can't keynote on just technical stuff, you have to sell a story. But we're not done. But this is where we are right now. We're not quite done. Because step 4 isn't then you get famous. Step 4 is you have to be famous already. This never works. If you want to just kind of be a mainstream speaker, giving technical talks at any conference, and just filling in where a conference can't slot in for speakers, that's fine. But if you really want to make an impact and have people listen to you, you have to already be famous. You do not get famous from doing talks, unfortunately. And when I say famous, what I mean is, in order for people to listen to a complex, nuanced message, like the message in this talk, you need to have enough bandwidth. You need people to be able to understand and put mental energy into trying to figure out what you're trying to say. Otherwise, anything but the high-level message will be lost on. So there are definitely people in the audience right now who, when somebody asks you, oh, how was that talk? You'll say, well, he said code quality didn't matter in the first 2 minutes. He had some nonsense on the screen about Python, but he said code quality didn't matter in the first 2 minutes. And I basically zoned out, so I guess code quality doesn't matter. It's how it is. I'm really shaking things up. No, yes, maybe, okay. But here's the thing. When I say famous, I don't mean like Wes McKinney famous. I mean like Drake famous. You have to be really big. And the reason for that is, you can see, even in the real technical community, one of the seminal results in distributed algorithms was Paxos. And Paxos took 9 years to get published. It is a very simple protocol. It is a seminal result, a solution for the consensus problem that only sacrifices liveness. It works fantastically well. It is it's the basis of a lot of very serious, large-scale engineering projects that need consensus among distributed systems. And it took him 8 years to get that published. He wrote the paper. Leslie Lamport, who was already famous at the time, wrote the paper in 1989. They didn't accept it in the journal because they said, you've surrounded it with too much fun jokiness. And he put it in his filing cabinet, and it didn't get published until 1998 or 1999. So even if you're just normal famous, it doesn't matter. So the question is, how do you become famous? And the easy way to become famous is through controversy. So that's kind of where we are right now. I'm going to shake things up, and we'll see how it works. So I'll tell you this. You've seen this talk before. And somebody just asked me about 10 minutes ago what the answer to is code quality. Does code quality really matter? What it is? And I'll tell you, you know the answer. Everybody here in the audience has seen this talk before and knows the answer. You've probably seen this talk twice before. And one time you saw this talk, the person said, oh yes, of course it matters. They said something like, oh, scaling is very important. You have to avoid technical debt or you'll be drowned in it. There's even a startup mentality, which is find the most complicated project that you can sell, and then use your technical expertise to execute on that, because your competitors will never be able to catch up. I always look at that and I think that's very much like how manipulative people work. I'm sure we've all worked for somebody who is psychologically manipulative, and what you'll notice is they tend to get really angry really quickly on issues that they know a lot about. The reason for that is you can ratchet the tension, and normal human beings always want to de-escalate a situation, so he puts them off edge and puts them into an area where the manipulative person has complete control, because they're more comfortable in dealing with high-tension circumstances. So that's a little aside, but that's the first version of the talk you see. The second version of the talk, the person said, no, it doesn't. And they said, well, time to market matters. Most startups pivot so many times. Most of the code that really exists after 5 years isn't the code that was written on the first day. User experience is much more important than code quality. In fact, we can just hire a bunch of people in some service center overseas and get whatever code we want. Unfortunately, when you saw both of these talks, they were not about code quality. And a very interesting thing that you might notice from both of these talks was the version that said code quality really matters was probably given by somebody who's a really good programmer, and the one that was about code quality doesn't matter was probably given by somebody who's not a very good programmer. You can see from the first demonstration where I kind of lied. Most of those talks were about promoting some political agenda. The code quality issue was just a side note. It was just, well, here's what's really important. I'm going to give you my agenda, but as a side note, here's why code quality does or does not matter. Those talks are garbage. Don't watch them. Don't think of them. Now let me tell you about something. The avant-garde, the stuff that I show you on the screen, the stuff that I do in my other talks, adding read watches to Python, adding AST literals to Python, I had one where I can write LD preloads in Python. It's not controversial. I thought it would be controversial when I first started giving talks, which is kind of why my Twitter handle is don't use this code. And my blog is at seriously.don'tusethiscode.com. And my email address is james@don'tusethiscode.com. I thought I could couch these kind of weird technical exercises in the don't use this code moniker, and it would de-escalate some of that tension. It turns out none of that stuff is controversial. The only time I've ever gotten in trouble giving a talk is I gave a talk about Python 2 versus Python 3. And what I said was, Python 3 is a good tool. There's a lot of effort being put into development. There's not as much effort being put into development in Python 2. There's some really cool features. Somebody yelled at me for 45 minutes in a bar afterwards saying, why are you telling me I need to rewrite my code in Python 3? And I told him, I'm not. I'm just saying Python 3 has some cool features. This was the only time I got in trouble giving a talk. And I didn't even really want to give that talk in the first place. Somebody said, hey, can you just talk about Python 2 and 3? So I thought, well, I'll give a very nuanced and very even-handed approach, because I personally have no stake in that political battle. So let me give you an aside before we really answer this question. What is good code? Who here in the audience knows what good code is? Who here in the audience knows what bad code is? You probably all have some metric regarding elegance or regarding composability with other code as to what good code and bad code is. I can take that metric and I can distill it to its essence. Good code is code that I wrote, and bad code is code that you wrote. That's every single time somebody tells you this is good code or bad code, it's always a reflection of themselves. The code that, if they say, well, good code is code that keeps it simple, they're probably people who write simple code. If they say good code is code that handles all the, knows all the features of languages and uses them expertly, it's probably an expert user of the language. It's a very meaningless metric, and it's always about promoting some political agenda. Because unnecessarily complicated code is code that you wrote. But the code that covers all the corner cases, that's the code I wrote. Self-indulgent, over-engineered code, putting more effort than we need into it, that's the code you wrote. The code I wrote is code that will scale and handle the problems we can't even see that are 5 months out, every single time. It turns out that in most organizations, things like code reviews are absolutely useless exercises. They're usually exercises in the political domain. They're not about the quality of the code at all. How many times have you, in the audience, been part of a code review process, and the entire process was, I'm going to keep projecting your code until you guess exactly what I want. Exactly. And that's how it works. The only way to do a successful code review is if the people doing the code review are in close collaboration and they have the same incentives to get the code to work, to be accepted as part of the system. Otherwise, it ends up in this political exercise between two people, and it doesn't benefit the organization. A similar problem I have, is how unit tests, most unit testing is not a scientific exercise of proving the correctness of the code. It's a bureaucratic exercise of proving to somebody that we looked at the correctness of the code, so if it screws up, you don't get blamed for it. So one way to do a good talk, never underestimate how far cynicism can take you as a speaker. So let's ask this again. Does code quality really matter? And I'll tell you what the answer is. It's not yes, it's not no, it's go away. Go away, don't ask this question, it's a bad question. But I'll tell you what that answer really means. It means that the only way for us to answer this question is to deconstruct the question. I told you this was a postmodern talk, and this is a typical technique in postmodernism. When you have two approaches or two viewpoints, you deconstruct them. You say both of these are absolute nonsense. We're going to find the middle path. We're going to question the question itself. So let's question the question itself. This question is so useless, so poorly defined. On my scale of pet peeves, it ranks even lower than benchmarks. And by the way, any slide you see, if you are at a machine learning or data science conference and there are statisticians and they're showing benchmarks of things on screen, and they don't tell you the median, the mode, the variance, the model, you know it's nonsense. How can, if you're a statistician and you're showing me a benchmark of this is faster than this, and I just gave you some numbers out of the blue for your area of expertise and said, well, in this mode it's 5, and in this mode it's 10, I won't even give you units. You throw me out the room. And yet, if it comes down to benchmarks, I guess it's okay. So let's think about how we can. Oh, let's go up. Okay. So let's think about how we can conceptualize this question. I will say that one of the presumptions I have is that most of the time the code that we're writing is some artifact of some business process. Some people in the world write code as an artistic expression. Some people write it just to indulge themselves in some area of their own personality, but most of us in this room who are professional programmers write that code as part of some business process. We may do an artistic expression on the side, but the code that we care about and the code that we're here to discuss is part of that business process. There's a simple model in place that I use to think about what it is around code. That business process has some component of it that's amenable to mechanization or automation. That mechanization or automation can be modeled, and there may be many layers of models. So you can say, well, here's a human process. I can cut out all the special cases. I can find some core of it. That core can be mechanized, and it's subject to certain assumptions. I can make a model off of that. I can express that model as some computer science model of using indirection of subroutines or mappings, and then I can take that model and I can encode it. I can encode it in a programming language. So I come from the finance industry. An example of this is, in the finance industry, I write code to support front offices to do a lot of analytics. So somewhere in the business, somebody picks up the telephone and buys and sells a bond or a CDS or an equity instrument, and they make money off of it. And there are certain components of it, such as tracking the P&L or the risk or the market value, that can be automated. A human being cannot take a blotter and write down every single trade and calculate statistics about DV01s or P&L for all of those. There's just too many trades per day for even a small desk. So you bring in some technology to facilitate this. That technology makes simplifying assumptions. And there are an enormous number of simplifying assumptions that it must make. And most of the time, people don't recognize or realize the simplifying assumptions that they are making. Simplifying assumptions such as the fungibility of instruments. CDS, for example, are bilateral contracts. Are they fungible? Well, if they have the exact same parameters from a calculation perspective, they're always going to calculate out to the same thing. But from the legal perspective and from a reporting perspective, maybe you need to represent them as separate line items. Another fundamental assumption is that things are linear. So the market value of some position is its market price times its volume. Well, that assumes there's a linear relationship between the volume and the market price. But in some cases, like in mortgages, you can have odd lots where very large lots have a different price than very small lots because they're less liquid. Those kind of assumptions get built into the model. At some point, once you have that model, I think as programmers, we almost never write out that model. We almost never even think about it. We jump straight to the encoding process. And the encoding process is we take that model, which is, okay, I want to calculate the P&L. So the P&L is the sum of the P&L for each instrument, or for each position rather. The P&L is the sum of all the cash flows for each position, and so forth and so on. We never really think that through, we just write the code. And when we write the code, we're encoding this model in some language. So we encode it in Python, we use some VSL, we use something like that. Oftentimes the distinctions between these encodings really just amount to spelling, especially in languages that are oriented around protocols like Python. So I'll give you a simple example. Here we have a generator. It's a fairly simple formulation in Python of a Fibonacci sequence using a generator. It's an infinite sequence. I can give you an exact same formulation that is differing in some small nuances, but for the most part will be identical in its use cases as a class. And the difference between the two of these is mostly spelling. Does the code quality here really matter, one or the other? I'm sure you can construct circumstances where one might be preferable to the other. But for the most part, they're just different spellings of the same fundamental idea, the same fundamental model. A difference in the two of them might be the fundamental assumptions they make about how they simplify the infinite profundity of the reality they're trying to model. Who's surprised that I could pull that sentence out of my mouth with no pauses at all? We're doing good so far. We only have 32 seconds left in this talk, so I really shouldn't give the meta talk, because that's wasting time for the main talk. But, it's Sunday, let's have some fun. I had a conversation with a speaker who was here earlier, and I can't tell you what library this is, but they were showing me something in a library, and it had this clone function. And here's just cut and paste of the code, and you can see it's gnarly, and it's ugly, and it's horrible. And I said, why on earth did you do this? Just use a meta class in Python, and you can see I can take all that nasty code and replace it with like 20 lines of code. And the response was, well, I don't want my developers to have to learn what a meta class is. And I said, well, do you want them to have to read through all this garbage code up here and understand what it does? Wouldn't you rather than read 20 lines of something simpler? And if they had a question about it, they could reference a book that would explain to them what a meta class is, rather than have to reference the users who wrote all this garbage about get args and get parameters. And there wasn't a real answer to that. But what you can see is, does the code quality here matter? I don't really know. Because in some cases you could say, well, if my users will never learn what a meta class is, you don't want to use a meta class approach. If you care about the correctness of the code, you have to use a meta class approach because the previous approach is broken in some fundamental ways. If you can tell your users, this approach is broken in some fundamental ways, but If you don't like it, screw off, then sure, go ahead with what you have already. There's no point in changing it. So what I can tell you is that it's mostly tautological to say that code matters when it does and doesn't when it doesn't. That's stupid, and I would be ashamed of myself if that's a talk that I give. Instead, what I can tell you is that you can construct a framework. This may not be the framework, but you can construct a framework where you're addressing this question honestly. And you can narrow the question in such a way that you can actually meaningfully answer it. So with the framework that I suggested, and the framework I suggested is circular and very presumptive, but with that framework, you can start to answer some of these questions very specifically without some of the political bias that comes in. Now there is some sleight of hand in that framework, but I'm not telling you that that's a framework we should use, just that it could be. So I'll tell you, this is postmodern, giving you a critical framework for understanding the question. It's not happening. So let's try and answer the question one last time. Does code quality really matter? Well, yes. Sometimes a certain encoding can be notationally better for human understanding. My generator talks are, here's a notation that's better for a human to understand, here's a notation that's not as good for a human to understand. That can answer the question very specifically with less controversy associated. Yes, some encodings are better, or can be composed with other encodings better, and you can see that. Talk to me about Python and some Python built-in protocols. There's ways you can do things in Python very tersely that composes with arbitrary libraries other people have written. Yes, sometimes encoding can be redundant. Sometimes you might build a large artifice on top of the system, but Python gives that to you already. This is one reason I like Python. It's a language that gives you a system in which to encode a lot of things. It gives you a lot of mechanisms that you can use. But what you can see is I can't answer this question for you. I can only give you the tools to answer it for yourself. I hope you've enjoyed this talk. I hope you've been riled up a little bit. And I know it's Sunday, and I'm so glad that you could all make it to this talk. I'm glad you could be here. I hope you've enjoyed the event. My name is James Powell. Thank you very much.